Uh, Hello everyone, welcome to our intro to programming video 2, and today we will cover two topics, which is recursion and object-oriented programming. A little bit about table content. We will have two main parts. The first part is recursion and the second is OOP. In recursion, we will bring to you what is the recursion, some easy example and some common mistake. And in OOP, we will have a little bit about principles and techniques, some real-world applications, instant versus class attributes comparison, and also a little bit of common mistakes.
So let's look at what is a recursion. So what I have here is a recursive function. I create a function that is named bomb, and then I call the function within itself, right? And then after this function finishes, I will print a bomb because the bomb will explode soon, right? Let's see. Okay, so we have a recursion arrow. What happened here? Oh, so because the function keep repeating itself, this is an infinite recursion, right? Because it keep calling itself, it will not stop. So let's put some condition here that will make it end. Let's see, count, and then how long I want to count this for? Count -1, right? I will count for 5 seconds. Okay, and will explode in count second. Okay, have to make this an extreme. Okay, let's see. Oh, still recursion arrow. Let's see why. Okay, 5, 4, 3, 2, 1, and then 0, and then -1. So we don't want this to happen. So what should we do here? In a recursion function, what you should have is the base case. So I just want to count this until 1, and then when the count is equivalent to 0, I will just return. Return here means just stop the function. Return here, return none, and we'll stop the function. So let me see. If it count 5, and then it will go up, count 5 here, and then will go here, and then it's not 0, it will print bomb will explode in 5 seconds, and then -1, it will be 4 here, and bomb will explode in 4, and then when it reach 1 here, when the count is 1, 1 minus 1 is 0. So when the count is 0, it will stop the function. So that's what we want. That's exactly what we want. Let's see. Okay, perfect. So yes, so this is a recursion function, a function that calling itself. But the very important thing is that you should have the base case. Let's see. Let's try another example. Let's try factorial. Okay, I have prepared here. So here, the same as the last example. So we have the function here, and we have the function calling itself within that function. And I will try factorial of 4. Let me try it. Okay, recursion arrow again. So you know what's the problem, right? Because we don't have the base case, so it keep calling itself even until the negative number. Let me put the base case in here. So what is factorial? Factorial means if I want to find the factorial of 4, it will be 4 multiply the next number, which is 3, and then 3 multiply 2, and then 2 multiply 1, until when it is if n equal to 0, the factorial of 0, we will return 1. So this is our base case. Let me see. Okay, 24. So why do we get this? So when we have the factorial of 4, if you put 4 here, and because n is not 0, it will return 4 multiply the factorial of 4 minus 1, which is the factorial of 3. But we don't know what the factorial of 3 is. So this function will stay here until we know what it is. So 3 will go back here again, and then because 3 is not 0, it will return 3 multiplied the factorial of 3 minus 1 is 2, but we still don't know what it is, so we have to go back here again. So 3 minus 1 is 2, so we have 2, and then 2 multiply 2 minus 1 with a factorial of 2 minus 1, which is 1. Because this is still not 0, we have to type it again. 1 multiplies the factorial of 0. What is the factorial of 0? When n equal 1, we return 1. So we go back here to complete all the function that is waiting for the number. So if you remember here, we have 1 here. 1 multiplied 1 is 1. That is a factorial of 1. And then when we have 1 here, we go back to here. The last time was this 2. So we know that factorial of 1 is 1, and 2 multiplied 1 is 2. So the factorial of 2 is 2. And then we go back here. We have 3 here. Factorial of 3 minus 2 multiplied to 2 is 6. Right. And then we go back to the last one that we have here in the beginning. If you remember, we have 4 multiplied the factorial of 3. Now we know that it is 6. So 4 multiplied 6 is equal to 24. So that's why we got 24 here.
Talking about another classic recursion problem is the Fibonacci sequence. It reads as the Fibonacci numbers may be defined by the recurrence relation of the zeroth number being 0 and the first number being 1, and the next number is the sum of the previous two numbers. So here's the code in Python for the Fibonacci problem. It has a base case of if Fibonacci 0 is 0, it will return 0, and if it is 1, it will return 1. And if the number is around 2 or more, then it will return the sum of the previous two numbers as mentioned here, returning Fibonacci n-1 and n-2. Printing Fibonacci 4 will give you an output of 3. So here's a quick visualization of how it works. Fibonacci 4 will be calling Fibonacci 3 and 2, and 3 will call 2 and 1, and 2 will finally call the two base cases of Fibonacci 1 being 1 and Fibonacci 0 being 0. And Fibonacci 2 over here will also call 1 and 0. We can see that Fibonacci 2 does appear multiple times, which is a function calling itself many a time, which is the basis behind recursion. Here are some common mistakes in recursion. A friend in the previous slides may have mentioned this already with a faulty recursive step where you do a recursion but you don't do the steps correctly, where this is n, which will result in an infinite loop, and it should be n-1, and over here where you have a missing base case, it will also infinite loop because it could loop to a case where you don't have the value for it, where it's not defined, and so it will result in an infinite loop like here, recursion error. And for the incorrect base case, the code will not give an error, but the result will be wrong. So give an example here. This is a function trying to find the sum of all the numbers in a list, but if in this line where if we try to return a list where it is empty, it will return 1, where it should be 0 because we're trying to find the sum of all the numbers here, not trying to find the sum of all of them and 1, where here this will give an output of 16, but the desired output is actually 15. And for the missing, okay, this is actually a missing base case. This is actually more of a test case, not testing all cases, where here we can see that the function wants to reverse all the strings, and this will give a perfectly normal output, whereas this, trying to reverse an empty string, is not included as a base case in this function, and it will actually give a recursion error and loop infinitely.
Wow, hello guys, I think all of us all know about this man. His name is Naruto, one of the most iconic character in manga in Japan. So imagine that you are building a system or a program and you want to store Naruto information. Yeah, we all know that it height, it weight, his friends, his family, or maybe his chakra type. But how can we store it? How can we store Naruto information, and how would we save this information? So that's why OOP appear. So what is OOP? OOP is a process of group all information of a real world object into a single structure. Yeah. Here's an example code about Naruto. You can see the code here and the output here. After giving the code, the output we have Naruto has a wind Rose chakra is 180 centimeters tall, weighs 60 kilograms, and his family include Hinata and Boruto and Himawari. Yeah, we all have all the information right here to the process here. I will explain it later. Yeah. Now, at that time, Naruto is not a fictional character. He became a programmer object. Yeah. Turning the real world concept into the code that is structured, usable, and easy to manage. That's OOP. Well, next we come to the structure of OOP. OOP have 4 core structures. First, class, methods, attribute, and object. We come to two first, class and attribute. Class is a blueprint or design plan to create objects. It defines 2 things: attribute and methods. Attributes are variables that belong to an object. They present the character as property of that object. And one more, that a class itself is not real. It's only describe how real object means the instant will look and behave. Yeah. Object means data plus behavior. An object represents things that has attribute, what it has, and method, what it can do. Methods. A method is a function inside a class. It's used for performing action with an object. Next. Well, imagine that you are working, you have a special anniversary or like birthday or something like. You want to celebrate in the hotel, so you want to plan it first. So you need to know when, what the day, the month, and the place, and how the weather at that time look like. So how can you store it? It has so many situations at that time. Use your OOP to store it. Next. Yeah. Here's an example and the 4 core structure. Firstly, you can see class here. It is a construction parameter, is attribute, method, and object. Let me explain more detail about it. Firstly, we define a class named weather. Next, the construction is run automatically a new object when it's created. Day, month, weather are parameters passed when creating an object. The cell refers to the current object being created. This slide creates attributes that belong to the object. Next, def birthday itself is an instant method. It belongs to an object, not a class. It's used self to access the object at the attribute. Yeah. What did it return? That it returns a format of discovery string. Yeah, return here. It's no problem about it. We have learned it in the function. First, later, outside the class, we have but whether that it is good is we are creating an object of the weather class. When weather is go, Python automatically run in its method. Finally, we just print it out.
Now it's my turn. I'm talking about the four corner principle. The first principle is encapsulation. This is about the protect data by hiding attribute and only allowing access to public function. It's called getter and setter. The goal is control the data coming and ensure the object stability. The next is enhancement. It creates a relationship between class. The child class can research the parent class feature without rewrite the code. For the example, a dog class inherits from animal class. This mechanism focus on the effect code research ability. Abstraction. This is the principle. Simplification. We hide the complex that detail and only show the necessary function to the users. The abstract class to define mandatory functions that all child class must implement. Finally, this polymorphism means many forms. This principle allows the same function call to perform different actions depend on the actual object. It makes our code very flexible and easy to extend when we add new object.
Now let's talk about the differentiate between an instance attribute and a class attribute. For example, in class person, we have a class attribute called family, which name 1. And when we initialize a new instance, we have two different attributes. It's called name and age. So let's start the example. When a class attribute, we build all the instances in the class may access to this family attribute. And if we change the family attribute, all of the instances are changed. However, an instance attributes are unique for each instance. For example, if we have two instances with different name and age, we'll use the keyword self to make the code understand that we access to the unique instance attribute. And of course, an instance can override the class attribute, but we not prefer it because it will affect all of the later coding when we access the instant class attribute. And now we will focus about a bank account with some simple use of OOP in the real world. Now we will create a class called bank account, which is unique for each bank. And now we have bank name, which is a class attribute with ABC Bank, and this attribute will be together for all the instance. Now we should initialize an instance with two main attributes, which owner is who and balance is how much money. And we have a little bit two instant method called deposit and withdraw. So deposit is mean that you put some more money to the bank, and withdraw is we collect the money from the bank. These two simple method when we use a bank account. Also that we see when we withdraw the bank account, we must check carefully if the amount are larger than the balance or not. And it's just a simple way to make our OOP doesn't corrupt it. And we have a class method which doesn't need the keyword self, but we need a keyword class. So class method may apply for all of the instance, and the data in the class method will be shared. We will link easily to the class attribute. And now I use the ChatGPT to create this code generally, and we have some usage with account 1. We initialize the bank account with the owner name by Ming, and the balance is 1000. Now we will print some bank account, the get bank name, which class method, and we'll have the answer as welcome to ABC Bank. And when we print the account deposit of 500, it will run exactly this method, and it will return 1,500. And the next one, when we withdraw 200, we will continue use the new self balance, which we modified by the deposit method. And now the new balance is 1,300. And that's all about our video today. We have covered the recursion, the OOP, and some application and common mistakes. To summarize, recursion is the type programming that we call a function into itself. In recursion, we have the base case and the recursive case, and some common mistake is like a stack overflow, wrong base case to wrong logic is often to us. And we will have to summarize the OP, we'll just focus on the 4 main principles with inheritance, impolitation, encapsulation, and abstraction. And to 4 of the basic instance of OOP called method, classes, instance, and attribute. Also, we provide you some basic application and also some common mistake about both recursion and OOP. And welcome to our team member is Ming, called Đặng Quang Minh, Trọng Nguyên. We have Chỉ Huy, Chỉ Kiên, and Việt Thành. And thank you for watching our video.